Hi there. In this video, we will go over Amazon Web Service Elastic Load Balancer. Now, from the definition of Elastic Load Balancer from the AWS documentation, Elastic Load Balancer automatically distributes your incoming traffic across multiple targets such as EC2 instances, containers, and IP addresses into one or more availability zones. It monitors the health of its registered targets and routes traffic only to healthy targets. Elastic load balancing scales your load balancer as incoming traffic changes over time. It can automatically scale to most workloads. From this definition come three important points which are important for the exam. First of all, Elastic Load Balancer makes an application highly available. The load balancer accepts incoming traffic from clients and routes the requests to registered targets such as EC2 instances, containers, or Lambda in one or more availability zones. Elastic Load Balancer is elastic to increase in requests. ELB, which is Elastic Load Balancer, is a managed service and it can automatically handle spikes in requests and return back to normal traffic. You can connect Elastic Load Balancer with auto scaling to ensure instances scale to spikes in additional client requests. Elastic load balancing can also make an application highly resilient to failure. This is because load balancer also monitors the health of its registered targets and ensures it routes traffic only to healthy instances or healthy targets. When the load balancer detects an unhealthy target, it stops routing traffic to that target. It then resumes routing traffic to the target when it detects that the target is healthy again. Now let's take a look at the various components of Elastic Load Balancer. In this diagram over here, we have highlighted the various components that are part of Elastic Load Balancer. There are the clients, there's the Elastic Load Balancer itself, there's the virtual private cloud, the listeners, the default rules and additional rules, availability zones, target groups, the targets themselves, and finally part of the AWS cloud. So let's go over each of these components one by one. First, we have the load balancer. The load balancer acts as a single point of contact for clients. The load balancer ensures that it distributes incoming traffic across multiple targets or target groups. So what are targets? As mentioned in the previous slide, targets are the EC2 instances or Docker containers or AWS Lambda. A target can be part of a single group, as shown over here, or a target can be a part of multiple groups, such as over here, where this particular instance is a part of target group B and target group C. Target group themselves route requests to one or more registered targets within the target group using the protocol and port number that you specify. A listener checks for connection requests from clients using the protocol and port that you configure. Rules. Each listener has a default rule. You can optionally define additional rules. Now each rule consists of a priority, one or more actions, and one or more conditions. You attach a rule to each listener. The rules define how incoming requests are routed to a target. Conditions. Each rule condition has a type and configuration information. When the conditions for a rule are met, then actions are performed. Health checks. Health checks are performed on all targets registered to a target group, and incoming requests are only routed to healthy targets. Sticky sessions for application load balancer. We will go over the different types of load balancer in subsequent slides. However, this concept is important. Sticky sessions basically are, by default, an application load balancer routes each request independently to a registered target based on chosen load balancing algorithm. However, you can use the sticky session feature, also known as session affinity, to enable the load balancer to bind a user session to a specific target. For application-based cookies, cookies have to be named specifically and individually for each target group. However, for duration-based cookies, AWS ALB is the only name used across all target groups. Then the final thing that is a component of Elastic Load Balancer are internet-facing or internal load balancer configurations. When you configure your load balancer, under the section for scheme, you have to choose either internet facing or internal. And An internet-facing load balancer routes requests from clients to targets over the internet. However, an internal load balancer routes the request to target using private IP addresses only. Now let's quickly go over the types of load balancers that are in AWS Elastic Load Balancing. AWS Elastic Load Balancing offers you 4 types of load balancers: the application load balancer, network load balancer, gateway load balancer, and the classic load balancer. The application load balancer functions at the application layer, which is layer 7 of the Open Systems Interconnection or OSI model. It is more feature-rich than the original classic load balancer and supports various methods such as support for path conditions, host conditions, supports for routing based on fields in the request, support for routing requests to multiple applications on a single EC2 instance, support for redirecting requests from one URL to another, support for returning a custom HTTP response, support for registering targets by IP address, including targets outside the VPC for the load balancer, and support for registering Lambda functions as targets. A network load balancer, on the other hand, functions at the layer 4 of the Open Systems Interconnection model. What is unique about the network load balancer? It can handle millions of requests per second. It is more feature-rich than the classic load balancer and supports some of the following methods: ability to handle volatile workloads and scale to millions of requests per second. There is support for static IP addresses for the load balancer. It supports for registering targets by IP address, including targets outside the VPC for the load balancer. The NLB or network load balancer supports for routing requests to multiple applications on a single EC2 instance. It also provides support for containerized applications and provides support for health checks. Then you have the gateway load balancer, which enables you to deploy, scale, and manage virtual appliances such as firewalls, intrusion detection and prevention systems, and deep packet inspection systems. The gateway load balancer operates at the layer 3 of the OSI model, also known as the network layer. Traffic to and fro from a gateway load balancer endpoint is configured using route tables. Then, the oldest of them all is the classic load balancer, which functions at the layer 4 and layer 7 of the OSI model. The use is being deprecated in favor of application load balancer. The use of a classic load balancer instead of application load balancer still has certain benefits because it provides support for EC2 Classic. Classic load balancer also provides support for TCP and SSL listeners and provides support for sticky sessions using application generated cookies. Now that we've understood the 4 different types of load balancers, let's take a look at the summary of load balancers. Now, if you go through AWS documentation, you can read through the link for product comparison of the various load balancers. We don't need to go through all of these things in detail for the AWS Solution Associate exam. However, for the Solution Architect Associate exam, you will need to know these highlighted concepts carefully, such as load balancer type, the target type, what is connection draining, cross-zone load balancing, and health checks. We will go over this in the next slide. In this final slide, we will now cover important concepts to remember about the Elastic Load Balancer for the AWS Solution Architect Associate exam. First of all, if you have a question where it is mentioned that registered targets are not receiving traffic from load balancer, then when you enable an AZ for your load balancer, Elastic Load Balancer creates a load balancer node in the AZ. If you register targets in an availability zone but do not enable the availability zone, these registered targets do not receive traffic. Prevent the load balancer from sending requests only to a single AZ. When cross-zone load balancing is enabled, each load balancer node distributes traffic across the registered targets in all enabled AZs. When cross-zone load balancing is disabled, in that case, each load balancer node distributes traffic only across the registered targets in only its availability zone. Connection draining. In order to avoid breaking open network connections while taking an instance out of service, especially for instances that have failed the health check, use connection draining. When connection draining is enabled and configured, the process of deregistering an instance from the Elastic Load Balancer requires an additional step. For the duration of the configured timeout, the load balancer will allow existing in-flight requests made to an instance to complete, but it will not send any new requests to the instance. During this time, the API will report the status of the instance as in service, along with a message stating that the instance deregistration currently is in progress. Once the timeout is reached, any remaining connections will be forcibly closed. Also, in order to ensure requests are being sent only to healthy targets, enable health check configuration. If a registered target is not in service, then in order to troubleshoot that, if health checks are failing, you need to check for the following additional issues. You need to check if a security group does not allow traffic, or if a NACL or network access control list does not allow the traffic, or the ping path does not exist. If you encounter a problem where clients cannot connect to an internet-facing load balancer, then check whether your internet-facing load balancer, if it's attached to a private subnet instead of being attached to a public subnet, or check whether a security group or NACL or network access control list does not allow traffic. So remember these important points for the exam. And now, having completed this, we have completed our overview of Elastic Load Balancer. In the next video, we will go over AWS Lambda. So thank you for watching our videos. Please hit the like button and subscribe and keep watching our videos.